Welcome back to the One Chart at a Time video series. We are getting ready to round out this section on graphs and charts and diagrams that are used to show relationships in your data. And so today we are going to talk about the correlation matrix. Now, many statisticians and mathematicians, economists probably think of a correlation matrix as a set of variables on one axis and another set of variables on the other axis, and the numbers within the table show the relationship, show that correlation or association between the different variables. But as you're going to see in today's video from Willem Tulp, there are lots of other ways to make your correlation matrix more engaging, make it easier to read, and make it more fun to read. So I'm going to hand it over to Willem so you can learn more about the correlation matrix.
Hi, John. Thanks for having me. I would like to talk about a correlation matrix. Now imagine you have a data set with several dimensions. And these dimensions have numerical values. What you can do, of course, is calculate the correlation between any combination of these dimensions. Now, what if you want to visually represent this set of correlations? One thing that you can do is show them in a matrix or a table or a grid. Every dimension has its own column, and every dimension also has its own row. At each of these intersections of a row and a column, you will then have the correlation value between these two dimensions. This value can be used to drive a visual property, for instance, the intensity of a color. What you then end up with is kind of a heat map where the strongest correlations have the highest intensity of color, so you can easily spot them. Now, there are a few characteristics of a correlation matrix that I really like. The first one, for instance, is the fact that data is duplicated, because since every dimension is used both as a column and as a row, you end up with a situation where you show the combination between A and B, but also between B and A, but obviously the correlation is the same. So this data is basically duplicated. And so what you can do is you can basically get rid of half of this grid. You don't have to, but it is an option and it allows for additional visual elements or extensions that you can design for this chart. Another thing that is really nice about a correlation matrix is the fact that each cell can be used in different ways. So in this first example, I told you that the correlation value can drive the intensity of a color, but each cell can also contain its own mini chart. And one thing that is very common to do is to show a scatter plot, which is based on the combination of these two dimensions. And the nice thing about this is that besides the correlation, for which you still could use color, for instance, you also see the spread of the data or the characteristic of the data, the individual data points. So that is a very nice thing to do. Another characteristic of a correlation matrix is that since you're using all the dimensions both for row and for column, you always end up with a situation at the diagonal where you have the combination between a dimension and itself, so the combination between A and B and B. Now, from a correlation perspective, this of course does not really make sense. So what's typically done when you use small charts in each cell is that for these particular situations at the diagonal, a small histogram is shown specifically for that dimension, so that you get an understanding of the distribution of the data for that particular dimension. Now, there are two examples I would briefly highlight, and the first one is actually a project I did myself for Scientific American several years ago, and it's the comparison between brain activity between mice and humans, and the question was raised, are mice good guinea pigs for testing several medicine and things like that, because brain activity differs quite a lot. Anyway, what I do like about this particular correlation matrix is the fact that you can add additional layers, and in this case you you see different groupings that have annotations. So you can group dimensions and highlight them. And so that's a very nice possibility and thing you can do with the correlation matrix. The other example I would like to highlight is the fact that you can also extend a correlation matrix by providing additional information. And in this particular example, you see at the top and at the left that there's some hierarchy drawn. This hierarchy shows you how each of the dimensions are structured hierarchically. And this is also very useful information for some particular data sets. So that's a very nice thing. And of course, there are many more extensions you can think of. So for instance, in case of this hierarchy, maybe you can highlight certain paths of the hierarchy or things like that. So that was my contribution. Thank you very much for having me, John. See you.
And thanks to Jan Willem for that great review of the correlation matrix. As you can see in his own work, he does use these in popular presentations and publications. So this is a strategy that anyone can use. It is, again, about thinking about your audience and how can you make something that you might think of as being just a staid old table, black and white text, into something that's a little more engaging with more icons, more color. So come back tomorrow. We're going to round out this section on graphs used to show relationships in your data, and then we're going to move to the last couple sections of data visualization types.